Okay, so now let's go into part two of the virtual textures. We're going to go over runtime virtual textures. So these guys run similar and they work in a similar method as streamed virtual textures, but this more is an approach of how you would handle it with landscapes. So first, let's go in here and let's create a landscape. So let's go to our modes. Let's go to landscape. And let's just create a brand new empty one. And let's throw in one of our landscape materials. I don't need a big one, so we'll just say, let's change our quadrants to about maybe 15 by 15. It doesn't have to be that big. Well, actually, maybe we'll do 31 by 31. So let's create. And then let's go into our paint mode. And let's designate our layer infos like before. And then let me start kind of painting some of these effects on here. And then now let's go into our sculpt mode. Let's just start sculpting up some shapes. So now we have a couple of these shapes. Now let me go and try and fix this little issue that we have here. There we go. So now we have a landscape and we have this rock right here that we want to be able to blend very well with the environment. Because right now we have him set up and he's just going to create this really harsh edge with our textures for this guy. Which of course that's not what we want. So I'm going to go in here real quickly and I'm just going to adjust our tiling for this guy. Let's bring him down to about 10. There we go. So he still has this very harsh edge. Let me go and adjust our player start so that we're not in the ground. And there's a couple different ways you can approach trying to blend this type of landscape information to the texture. One way is using pixel depth offset to kind of create a fake transparency to the detection of this edge crease that we have. And that will help a little bit, but it's not going to give you the information blended to the texture. Um, it's just a cheap way to make it seem like the line is not so harsh. This approach, how it's going to work is it's going to take the information here and it's going to create a texture on it. It's similar to the method of a render target. So what a render target is it's a type of image, like a texture image, that will take actual information here and render it to a flat texture that you can later on use for different things. Here we're going to approach it in a different way. So let's go to our landscape. And in the landscape settings, there is a setting for virtual textures. So here you can actually create your own virtual texture. So we're going to do two. Our first virtual texture, we don't have any here yet because we haven't created them. You can actually go up to this little menu right here. It says create new assets and do a runtime virtual texture. And we're going to save it here in the VT area. And we're going to do RVT, landscape, base. And then we're going to hit save. And you can actually go in here, and this is all your settings for your runtime virtual texture. You can adjust the actual resolution for this guy here. And then you can actually adjust the contents of your texture itself. So by default, it has base color, normal, roughness, and specular. We're not going to use specular because we're not handling specular levels. We're going to be using the base color, normal, and roughness information. The reason why it doesn't have metallic is because naturally speaking with landscapes, there's nothing naturally forming that would use metallic in the ground. It's normally like a prop or a static mesh would have the metallic values. So that's why they don't have it here. And sadly, there is no support for ambient occlusion as of right now. So we'll just do our base color normal roughness. And then by default, it'll give you some simple texture compression. And then we'll hit save. And then let's go here to our second one. And then let's create another one. Same thing, save in the VT. This one we'll call RVT landscape height, because we're going to need the actual landscape height of this world. That way we can figure out where the world ends versus the object itself, and then figure out a way to mask out everything. So we'll hit save. And then here, we'll right click on this height texture. And since it's a height map, we don't need as much detail as, say, this landscape base, because it's going to have the texture details, the normal details, and roughness. We just need some simple height. We don't need anything, so you can keep it at 256, but you need to change to world height. That way it samples something different than this guy does. So we're going to hit close, and then we already have them attached to this landscape. The next thing we need to do is we need to bring in a type of volume. So here in the place actor setting, we're going to go to virtual, and you're going to bring in a texture volume. Just drag it in. And then you can select your actor because what's going to happen is this volume is going to bound to this landscape so that we can actually capture everything that's inside that the bounds are. So you can actually select your actor here. So we're going to select our landscape. Then you'll do snap to landscape. And then you'll bring in a texture. We're going to do our base height first. And then you'll do set bounds. And naturally speaking, it does its best, but it's still, it's not perfect. Before, in earlier versions, there was a way to actually adjust for rotation as well as position. So it's going to try and approximate as best as it can. So it's just going to capture enough space around the landscape. And that's what we need. So we already have our virtual texture where it's pointing to, and we have the bound set. Now let's make another one. This one is going to be for the height to capture. So we'll do the same thing. We'll apply our landscape. We'll set the bounds, and we'll snap. And then what we're going to do is we're just going to make some small adjustments. Essentially speaking, we're just going to grab the position information for this guy. Make sure it shares all the same information, and it's going to capture everything. Okay. So now we have both of them set here. Next, what we need to do is we need to take these virtual textures that we've applied and bring them inside of the landscape material. So I'm going to go to where our master material is, and I'm going to go inside. And since you've already applied the virtual textures inside the settings, you're going to get a bunch of new nodes. So we're going to type in runtime, and then we're going to need our output, and then we're going to need our runtime sample. So what these are two nodes that use inside of this. This runs similar to the dual normal. So this will be our actual output for all of these samples. So I'm going to grab our albedo information. I'm going to grab our, actually no, this is, yes, our albedo information. I'll grab our normal information. And then I'm going to grab our roughness information. Because like I said before, you're not going to need the ambient occlusion or metallic. Those settings will not work here. And then we're going to do our base. And then since we already have this output, it's going to output all that information here. And we'll plug it in. Plug that in. And plug that in. And then we're going to hit save. And it's going to calculate just a little bit because it needs to bake out all that information that we just had inside the landscape onto an actual texture. So that's one thing it's doing, is It's baking out all this information, and instead of it taking before in the landscape texture and material setup on runtime, it's calculating all these nodes that we were using for these like layer lerps, and then it was calculating them all at the same time on runtime. Now, since we have this output and input, it's now baking out all this information and creating an output that actually only samples once as a texture. So we'll hit save. It's going to recalculate just a little bit. But now we'll essentially have everything texture-wise inside this setup. It's baked exactly the same way. Now, the next thing we need to do is we need to go here to our test material that we made. Let's grab the instance, and then let me grab here. And now let's bring in 2 samples. So let's go and do our right-click and type in runtime. And we're going to do 2 samples. If you would like, they do have parameter support. So if you want to just take create a master material out of this, and then if you have multiple landscapes that you want to apply this to, you can do that. So we're going to go here, and we're going to do our base, and then we're going to do our height, which since we've already set our samples, it will adjust the texture samples that we need. So this guy is going to be used with a couple lerps. So we're going to have 3 lerps. And that's going to be over there. And then here we have our height information. We only need one thing with it. But next we need to take a couple bits of scene information to kind of calculate where our rock is in accordance with the landscape itself. So let's first grab some world position. And then let's grab some object bounds. There you go, object bounds. Because we don't need object scale, we don't need object position. We need the boundaries of the object itself and how it is approaching this object. So next, what we're going to do is we're going to grab some component masks, because we're going to mask out the B channel, the blue channel, because in relations of position, it's height. Because your red represents the X direction, G represents the Y, and B represents the Z. So we'll grab that and grab another one. We'll plug both of those guys in. And then what we're going to do next is we're going to create a subtraction with the world position of our the world position of everything, and subtract it with the actual height information of the landscape. So that's going to create our distance between the world and the landscape. And then next, what we're going to do is we're going to add that distance to our boundary. By definition, it's going to basically figure out where our object is in accordance with this guy. Next, what we need to do is we need to apply just a little bit more information. So we're going to subtract that object bound so that we can create another difference and create a mask where the intersection of the 2 objects are. So we're going to hit a multiply. Oh, not. We do need another parameter, but this parameter is going to be for our height so that we can actually adjust some things. So we're going to multiply that with our mask. So this is going to create the object bounding height that we're going to adjust. And then normally when we play around with this, it's going to be very, it's going to take a while. So just to make sure that our values aren't like really, really high, we're just going to multiply it with a value of 2. So it's just going to double it. So it's, context wise, when we're doing this for user input, it's going to be a lot smaller number instead of a very large one. And so next what we're going to do is we're going to subtract the information that we've already provided with the distance with this height information. That way it allows us to subtract the difference between the object where it is in position with the landscape and then with the actual adjustable height. So this actually will create our mask that we can adjust where the blend kind of starts and ends. So by definition, when we do this and we adjust this value, we can adjust how far the blend goes up and down the object. So actually, if we want to, we can actually go in here and I can adjust our base color. Let me hit save and go to our instance for this guy. Let me move him around and let me do 1. So by definition already, we already have our mask of where this object is. And if you want to, you can actually move it. You can rotate it as well. You can actually do like zero point 0.5, actually maybe 0.65, no, 0.75, 0.8, 0.9, there we go, 0.95. So it's slowly getting that information. If you want, you can even adjust your rock a little bit. So we already can see that the mask is working, but now you kind of can see that this it's a very sharp edge. We don't want to have the blend to be this strong. So what we can do next is we can go into our subtract node, and then we're going to do divide. And what it's going to do is we're going to create another sample or another parameter for blend, and we're going to divide the amount of samples this guy has so that it can actually soften our shape. So let's go here. We're going to change this to blend. And then let's plug him back into the base color and test that out again. So let's blend it by 2. Let's blend it by 10. So you can see it's already starting to divide that variation multiple times. So let's do 25. So it's actually creating this kind of soft value for us. And then, of course, if you want to, you can adjust like 0.94, 0.92. You know, we see that it now works. So one thing we also want to do is sometimes these values might act a little funky. So we're going to do a saturate node, which saturate makes sure that these values are going to be 0 to 1. That way we don't have any problems in the long run. This basically acts just like a clamp node, but there's no user input set. This is just a just in case thing, in case maybe when we start putting in some of these values that they might go over or under the 0 or 1. We don't want anything above a 1, and we don't want anything below 0. So we see that it now works. So now let's start plugging in some things. So here we have the albedo. We're going to plug it in here because as you see how the mask works is whatever's going to be white in our lerp is going to be the rock. And then whatever's black in our lerp is going to be the texture information that we're going to get from this virtual texture sample. So we're going to grab the base color for here and put it into the A slot for the B. And then we're going to grab the saturate node that we had just done and then plug that into the base color. And then we're going to do the same thing for our normal map. Plug in the normal map. Plug in the normal information. And then we're going to do the same thing for the roughness texture as well. So green channel. Actually, no, I set it to the wrong one. Actually, no, I did set it to the right one. Here's the one I need, the roughness value from here. And now let's apply to our roughness. And now let's hit save. So it's going to take a little bit of calculations and boom. So here you can actually see if I start moving it, it actually starts to blend this texture information a bit. And of course, it's going to look a little weird. And that's just because the landscape is like coming from a very sharp angle. If you want to, of course, just go in, adjust the height information. So we can do like 0.94 or even like a 1. And then like adjust some of this information a bit. And then what you can do is you can go back to your landscape. And then let's make our brush a little small. And let's change our strength just a little bit. And then let's sculpt. Like I said, all you got to do is just, add just a little bit of softness. Like bring these values up and then just kind of smooth it out or even apply some erosion or something. And then let's go back to our selection mode. Rotate just a little bit. And there you go. Now, of course, you can adjust some things like some tiling and some stuff here and there, but that essentially is a way to take our landscape information and blend it to our object. Um, technically speaking, it's still very hard to do with other static meshes because it has to calculate a bunch of objects. This works because the landscape has one material set up for all of these layer blends. It's only unless you have like a static ground that is using one material for all the ground stuff is the only way for this to work. So this essentially is the second approach of how you would use virtual textures within Unreal Engine.